In this video, we are going to take a look at variation functions. Variation functions are going to start looking at models, and these are going to be incorporated into our models. That'll be in the second video. Right now, we're going to look at what makes up a variation function, what does the general formula look like, and then we're going to go back and look at linears and exponentials as well. So to begin with, we have the following situation. Y varies directly with the nth power of x. If that's the statement to the problem, then our equation for this is y equals, as soon as I say varies, that's a k, and then with the nth power of x, x to the n. That is a direct variation. Y equals kx to the n. So now my base, my x is my x value, and my power is going to be a specific power that we will know. Differing from exponentials, where that power was the unknown before, now it's going to be the known. Now that's a direct variation. The second one is an inverse variation. So that's y equals, as soon as it says varies, it's that k constant again, over x to the n. That's an inverse variation. So if you know, either you can tell it's an inverse variation based on the information that you're given, or if it tells you in the story it's an inverse variation, the x to the n is going to go in the denominator. The k is some constant of variation, which we'll be able to calculate, and the n is that degree that it is going to. So we're going to start with, before we get into variation, we're going to go back to that add property. Remember the add property? The add property starts taking a look at linears. So the add property deals with linear functions. So if I remember, it adds on the left-hand side and adds on the right-hand side. Now please keep in mind, as you guys saw in examples, that sometimes it might skip some values along the way, and you may have to fill in some of those values in between in order to determine that it is linear. Now if it is linear, you know the equation, y equals mx plus b. So my slope is my y's over my x's. So my m is 5 over 2. If you don't remember that, do the slope formula. And then b is my y-intercept. So if I can go backwards and find my 0 value for x, that gives me my y-intercept. So subtract 2 gives you 0, subtract 5, and that gives you your y-intercept of 5. Otherwise, plug in your x and y, solve for that b value. Just plug in a point for x and y, solve for that b value. So that's your linear doing the add property. So if you have a table of values and you're adding on the left and adding on the right, it's just going to be a linear function. Differing, of course, from the add multiply property. If you remember, this is our exponential. Now, I'm going to tell you this right now. If you do not know how to calculate the equation for an exponential equation, you need to go back to Unit 3 and take a look at exponential equations. We may have exponential equations on our story problems that we're working with on the real-world application. So please make sure you go back and you feel comfortable writing an equation for an exponential. Exponential is y equals ab to the x. Again, this differs from our variation because the x is our exponent, versus in variation, and n is our exponent. We'll know what n is. So that's one of the big differences between exponentials and variation, in addition to the way the graphs and stuff look. Okay, so now, in order to find an exponential equation, in this problem, it's really nice because I have a 0 value, 0 for x that is. So when I plug that in, 2 equals ab to the 0, b to the 0 is 1, therefore a is 2. And then rewrite your equation, plugging in another point. Let's say 2 and 6. So 6 equals 2, which was our a, times my b value, which I don't know, to the second. So solve this. 3 equals b squared. B therefore equals the square root of 3. Rewrite my equation. Y equals 2 times the square root of 3 to the x. So there's your exponential. This was a nice case because I could find that x value of 0. So just be careful with that. If you can't, then you have to set up a system of equations. Now we're going to look at multiply. This is the new process. Multiply, multiply is the third case. Add is linear, add, multiply is exponential, and multiply, multiply is variation. And this variation will either be y equals kx to the n if it's a direct variation, or y equals k over x to the n. So let's do the multiply, multiply part. Make sure that, yes, it truly is multiply, multiply. So on the left-hand side, I'm multiplying by 2 each time. It works. On the right-hand side, take the second, divide it by the first. Because it is decimals, you have to think a little bit more. This is multiplying by 4. You can keep going, check out, make sure that does work. So this is a multiply, multiply situation. Because it is multiply, multiply, I'm going to use one of these two equations here. Now, one of the things that happens, this is a shortcut to determine whether it's a direct variation or an inverse variation. Both of these sides are increasing, which means it's a direct variation. Our n value is going to be positive. If this side was increasing and this side was decreasing, then it would be an inverse variation and my n would be negative. We're always going to start with this generic function, and if n is negative, it will push it to the bottom, and it will be this one. So please keep in mind that we always start with a direct variation. If n is negative, one goes up, one goes down, it's going to push that part to the bottom. So now I have to look at how do I come up with my equation for this. I start by finding my n value first. My n value comes as follows. 2 to the n equals 4. What you multiply by here, 2, to the n equals what you multiply by here, 4. And I can factor tree this. Sometimes I'll have to rearrange things. This is just going back to exponent properties. And some of you know already, oh, well, I know that has to be a 2. If you're not sure, again, do the factor tree. 4 is 2 squared, so bases are the same, therefore n has to equal 2. So I know right away, since n is positive, it is a direct variation. So y equals kx squared. That's all you have to do for n. What you multiply on the left to the n, how many times do I have to multiply that to get what I multiply on the right by? Because it's a multiply process. So now I have to figure out what my k value is. That's the other constant I have to figure out. I have to find n and I have to find k. So I plug in a specific point. Whichever point makes it easiest for you, I'll just plug in the first point. So 0.8 is my y equals k times 2 squared, which is 4. Divide both sides by 4. K therefore equals 0.2. So my final equation for this is y equals k, which is 0.2 x squared. So there's my variation equation according to this set of coordinate points. Okay, I'm going to give you another one I want you to work through. And I want you to do this. Set up your equation. See if you can figure out what everything should be. So here's my next problem. I will start by saying these values are increasing, these values are decreasing. Because of that, I know it's going to be an inverse variation. I am, however, going to start with y equals kx to the n. My n value will push it to be exponential, or excuse me, will push it to be an inverse variation. So pause it right now and come up with what you think you should do along the way. So on the left-hand side, I'm multiplying by 2, and on the right-hand side, it's multiply. I'm multiplying by 1/8. Take the second, divide it by the first. Take the third, divide it by the second. So what I multiply by here, 2, to the n, equals what you multiply by here. So now I have to go through. So this is 2 to the n equals 1 over 2 cubed. Can't have that down there. I want bases to be the same, so I push it. So 2 to the n equals 2 to the negative third. Therefore, n equals -3. So my equation is y equals kx to the negative third. Negative exponent attached to this base takes the base and the exponent and pushes it to the bottom. Therefore, my equation is y equals k over x cubed. This is an inverse variation. Now I plug in a physical coordinate point. Again, it does not matter which point you plug in, just pick one. I'll pick the smaller one, 8 and 4. So 4 equals k over 8 cubed. Go through and do my calculator, take 2 cubed, multiply both sides, 8 cubed, multiply both sides by 8 cubed. K therefore equals 2048. So my equation therefore is y equals, I found my k value, so this is the equation I'm working off of, 2048 over x cubed. Again, this is a variation. It's an inverse variation. That is important to know the difference between direct variation and inverse variation. And this is how you find your equation. So practice a couple of these. Make sure you're comfortable with them because we're going to work with these in story problems as well. We're going to do the real world part of it. And you have to make sure that you're comfortable doing the variation equation.